Have you ever wondered what really makes a brain smart? I mean, is it just bigger or faster? People have been guessing for centuries, but today we're going to look at what neuroscience actually tells us. And trust me, the answer is way more interesting than you might think.
So think about it for a second. The last time you hit a problem you had zero experience with, maybe a weird puzzle or trying to figure out a new piece of tech, how on earth did your brain even start to solve it? Well, that ability to think on your feet, that's really the core of what we call intelligence. And it's the big mystery we're diving into today.
All right, to get to the bottom of this, we first have to get one thing straight. Intelligence isn't just one single thing. Way back in the 1960s, a psychologist named Raymond Cattell figured out that it's really made of two major parts. And these two parts are the crucial clues to solving our puzzle.
So let's break it down. On one side, we have what's called fluid intelligence. You can think of this as your ability to think on your feet, to solve brand new problems. And on the other side, we have crystallized intelligence. This is basically your brain's giant library of all the facts and skills you've picked up over your life. Two totally different but equally important ways of being smart. Okay, let's zoom in on fluid intelligence. Imagine you're trying to assemble some IKEA furniture, but you've lost the instructions. Or you're trying to find your way around a city you've never been to before. You're using pure logic and pattern spotting to figure things out. That right there, that's your fluid intelligence at work. It's your raw, adaptable, problem-solving power.
And then you've got its counterpart, crystallized intelligence. This is literally everything you already know. Knowing that Paris is the capital of France, understanding what the word eloquent means, or even just knowing how to ride a bike. All of that is your crystallized intelligence. It's the hard-earned wisdom you can pull right out of your memory banks.
So that's the theory. But what does all this actually look like inside the brain when it's happening? Well, to figure that out, we're going to look at a really cool study from Frontiers in Human Neuroscience. Scientists basically designed the ultimate puzzle to watch fluid intelligence in action. So here's the setup. The researchers got a bunch of high school students, and based on some tests, they split them into two groups. You had one group with high fluid intelligence and another with just average fluid intelligence. Then they put them into an fMRI scanner so they could literally watch their brains work in real time. And this was the puzzle they had to solve. It's a classic test for fluid intelligence. They'd see a pair of abstract shapes, let's say A and A prime, and they had to figure out the rule that connects them, like maybe it's been flipped upside down. Then they'd see a second pair of shapes and have to decide, hey, does this mu pair follow that exact same rule? It's a pure test of logic. No prior knowledge helps you here. Now, because they were using an fMRI, which tracks blood flow, the scientists could see exactly which parts of the brain were lighting up while the students were wrestling with these puzzles. They were basically scanning for the signature of intelligence itself. Okay, so before I show you the results, what would you guess? I mean, the common sense assumption is that a smarter brain would just have to work harder, right? It would light up like a Christmas tree, burning more energy to get the answer. But is that actually what they found? Real quick, to understand what they saw, we need to know about the brain's geography. Most neuroscientists now believe in something called the Pareto-frontal integration theory, or PFIT. All that really means is that intelligence isn't in just one spot. It's like a superhighway of communication between the parietal and frontal lobes of your brain. And this study was basically watching the traffic on that highway.
And this is where things get really, really interesting. The results from those brain scans didn't just challenge that harder working brain idea, they pretty much flipped it completely on its head. Okay, so first, the researchers looked at the parietal lobes. These are the parts of the brain doing the actual heavy lifting on this kind of spatial puzzle. And here, the high IQ brains actually showed more activity. They were putting more of their resources right on the problem. So far, so good. That makes sense. But, and this is the huge twist, when they looked at the frontal lobes, which acts like the brain's manager, the CEO that monitors and controls everything, the high IQ brains showed less activity. They were spending less energy on managing the task. They weren't working harder overall, they were working more efficiently. This led the researchers to this incredible insight. They said it reflects a lower demand for executive monitoring. In plain English, the smarter brain didn't need a manager breathing down its neck, checking its work all the time. It just did the job. And this whole idea has a name, neural efficiency. So what is this neural efficiency really telling us about what it means to be smart? Well, it seems the big secret isn't about raw power. It's about something way more elegant.
having a flexible mind.
And that brings us to the core concept here, the neural efficiency hypothesis. It's this idea that higher intelligence isn't about using more brain power. It's about using it more wisely. It's like the difference between a sputtering old engine that guzzles gas and a modern, finely tuned engine that gets the same job done with way less fuel. So let's just put it all together one more time. The high IQ brain pumped more energy into the specific brain regions that were actually solving the puzzle. And it wasted less energy on managing the process from the front office. The result? Super efficient, super accurate work. It wasn't about working harder, it was about working smarter, right down to the level of your neurons.
And that gets us to the big takeaway. The study found that a key ingredient of high fluid intelligence is the brain's ability to be flexible, to shift its resources and direct power exactly where it's needed, from one moment to the next. It's that incredible adaptability that truly defines a smart brain.
So how does this play out over our own lives? Well, what's really interesting is that our fluid intelligence, that flexible problem-solving skill, often peaks when we're in our late 20s. But our crystallized intelligence, that library of facts and knowledge, can actually keep growing for decades. It gives us a different kind of wisdom as we get older.
And that leaves us with one final, really important question to chew on. If the true hallmark of intelligence is this mental flexibility, then how can we train our own brains to be more efficient and adaptable? Now that is a puzzle worth thinking about.